Hi students. So let's start our new topic, equivalence relation. One of the most important relation which plays a significant role in metrics is an equivalence relation. To study equivalence relation, we first consider the three types of relation, that is symmetric, reflexive and transitive. Okay, so let's get started. Even though the relation would be one set to other set, however here we talk about equivalence relation, we would be discussing a relation which moves from A to itself. That is R from A to A. Let's take them one by one. First one is reflexive. A relation R in set A is called a reflexive relation if A comma A is an element of R. For all A is an element of A. So let's move to one example. Let us consider a set A consists of elements 1, 2, 3. If I want this which are given relation constructing to be reflexive, so if I pick this one here and 1 should be element of R. Similarly, if I pick up 2 from here, 2 is an element of R. And similarly, if I pick up 3 from here, 3 should be an element of R. That is our relation containing elements 1, 2 and 3. Okay. Even one does not lie. That is, if I pick up 2, that is 2 is not in given relation, then it become not reflexive. In other words, you can also write it as A related to A. Instead of writing A comma A is an element of R. That is, element is related with itself. Such a relation is said to reflexive relation. Okay, I hope you understood. Next we move to symmetric relation. If I take two elements from the given set and I say A, B is an element of R, if I want this relation to be symmetric, in that case this must implies that BA also must an element of R. So moving back to the same example, let A equal to 1, 2, 3. Let's say in the relation I put 1, 2 as lies in the relation. For this relation as symmetric, provide 2, 1 is also in the relation. Okay. And what I am trying to say that if I pick up any one pair here, then the reverse of it should also belongs to our relation R. That is, AB is an element of R. BA also must an element of R. Okay. And if my relation consists of elements 1, 2, 2, 1 and 3, 1. And if I pick up 1, 2 here, the reverse 2, 1 is also present in this relation. So this is symmetric, and if I pick up 3, 1 here, the reverse 1, 3 is not present in this relation. So we cannot say that it is symmetric. Okay. Next one is transitive relation. In this case, I am going to take 3 elements A, B, C from the given set. That is, A, B, C is an element of A. Okay, if I am saying A, B is an element of R and B, C is also an element of R. And note that here the second element should be the first element in the next one. This implies that AC is also an element of R. Then we say that the relation is transitive. Okay. AB is an element of R, BC is an element of R, which implies that AC is also an element of R. And this is the condition of transitive relation. So taking the same example once again, let A equal to 1, 2, 3, and my given relation has the elements R equal to 1, 2, 2, 3, and we need to make sure that 1, 3 is in the given relation. Such relations are called transitive. That is 1, 2, 2, 3 and 1, 3 is also present in this relation, and such relation is called transitive relation. I hope you understood all these 3 relations. A relation R in a set A is said to be an equivalence relation if R is reflexive, symmetric and transitive. Okay, I hope you understood. So let's do one question. In this question, we have given a relation of set A and we need to determine whether the relation are reflexive, symmetric and transitive. So let us start the solution of this question. Given that set A equal to 1, 2, 3, 4, 5, 6 and the relation from A to A is defined as the ordered pair x comma y such that y is divisible by x. So first of all, let's write all the pairs of relation. So our relation will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 2, 2, 4, 2, 6, 3, 3, 3, 6, 4, 4, 5, 5 and finally 6, 6. Okay. So let's check it for reflexive. So what is the condition for reflexive? If A is an element of A, then A comma A is an element of our relation. If we can observe here, for every element in set A has ordered pairs 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That is 1, 2, 3, 4, 5, 6 is an element of A. 1, 1. Ordered pair 1, 1 is an element of R. And if I take 2, 2, 2 is an element of R. If I take 3, 3, 3 will be an element of R. And 4, 4, 4 is an element of R. Similarly, 5, 5 is an element of R, and 6, 6 is an element of R. So every element of set A has ordered pair, and which is also an element of R. So therefore R is reflexive. Okay. Let us check for the symmetric relation. And in symmetric relation, AB is an element of R, which implies that BA is an element of R for all AB is an element of A. So observe that 1, 2 is an element of R. 1, 2 is an element of R, but 2, 1 is not in the relation. 2, 1 not in the relation. Therefore R is not symmetric. Not symmetric. Next we check it for transitive. What is transitive relation? If AB is an element of R, BC is an element of R, then AC is element of R, which will give a transitive relation. So let's check it for transitive in this question. So we can see that 1, 3 is an element of our relation, and 1, 3, 3, 6 is also element of our relation, and and check it. 1, 6 here also 1, 6 present, right? So 1, 6 is also element of our relation. Therefore it is transitive. This is our next question. In this question we have given a relation of set A, and we need to find out whether the relation is reflexive, symmetric and transitive. So let's begin the solution. Given that A is a set containing numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. And the relation from A to A and is defined by R equal to x comma y such that 3x minus y equal to 0. From the given relation we can write it as 3x minus y equal to 0 or y equal to 3x. That means the second coordinate is 3 times the first. Second coordinate is 3 times the first. So our relation will be equal to, if x equal to 1, y equal to 3, and if x equal to 2, y equal to 6, and if x equal to 3, y will be 9, and if x equal to 4, y will be 12, and 5 is not here because if x equal to 5, the y will be 15, and which is not available in the given set. So this is our relation. Okay. Now let us check for reflexive. And we know that what is the condition for reflexive relation? If A is an element of R, A comma A is also an element of R. Okay, so we can see that if 1 is an element of A, but 1 is not an element of the relation. Similarly, if we get any number in set A, we cannot get the ordered pair in our relation. So we can say that this is not a reflexive. The relation is not reflexive. Now let us check it for symmetric. We can see that 1, 3 is an element of relation R, our relation R, but 3, 1 is not an element of our relation. So therefore R is not symmetric. We know that what is condition for symmetric? If AB is an element of R, it implies BA also an element of R. So if this condition satisfies, we can say that the given relation is symmetric, but here it violate this condition, so this is not symmetric. So let us check it for transitive. So let us check it for transitive. Let us take 1, 3 is an element of R, and 3, 9 is element of R, and if it is transitive, 1, 9 should be an element of R. But we can observe in the relation 1, 9 is not an element of R. Therefore, the relation is not transitive. Okay, I hope you understood.